Alrighty, we're going to go ahead and get started. So, my name is Garrett Barrio. I work with Gensco Tech Services and one of the Mitsubishi DSGs. Today, we're going to be going over the Intelli-Heat dual fuel system. The Intelli-Heat, why are we getting into it? It's opportunity. 52% of the market are still currently natural gas or LP. Mitsubishi wants to get in on that market, and they want to own the heat pump market in it. In order to do that, we've created the PAA coils. That way we can share the market with gas furnaces. With our coils, we can extend the shoulder season by offering very high COPs, reduce fossil fuels and carbon emissions by up to 40%, provide efficient heating and cooling year-round, and conform to greenhouse gas reduction efforts through partial electrification. You can see in the pie chart there that currently 48% of our market is LP, or utility gas, excuse me, and about 4% is LP, bottled or tanked gas, and about 9% is other, and only 39% is electric. So, like I said, Mitsubishi is wanting to get in on a bigger piece of the market share, and with the Intelli-Heat, that's what gives us the ability to do that. Right here, this is a good example of what the Intelli-Heat is. This is an example of a one-to-one system. As you can see, we got our one-to-one PUY or PUZ heat pump with our Intelli-Heat coil sitting on top of our gas furnace. On a one-to-one system, it can be used as a cooling only on a PUY. It can be hooked up to a PUZ heat pump, a hyperheat, anywhere from 1.5 to 3.5 tons. By the way, I forgot to mention it. I have Aaron Larson here. He's going to be helping out with the chat. If you guys have questions, please type it in the chat and he'll get it to you as quick as he can. If we don't get back to you, we'll have an open session at the end for people to talk and ask any questions they may have. Operation of this unit takes any of the Mitsubishi thermostats or a 24-volt thermostat. We'll get into that a little bit later, but it'll hook up to your Intelli-Heat control panel. Intelli-Heat control panel will hook by a 24-volt conventional stat wire to your gas furnace. Your coil and your heat pump will communicate through your normal 14-3 wire, S1, S2, and S3. And then also you have your line set, obviously, going to the unit there. These units can also be used on a multi-zone system. So MXZs, smart multi, and ported systems. We'll get a little bit more into compatibilities on that in a little bit. Here's an example on a branch box system. So you can see we have our heat pump here, MXZ heat pump with our branch box, going to 2 different indoor units. Standard wellhead here with our Intelli-Heat coil. Again, standard S1, S2, 3 wiring going to your coils there. One thing to note is on the ported systems or multi-zone systems, max is 3 ton. 1.5 to 3 ton, whereas you could look at the one-to-ones, you can go to 3.5 ton. Applications for the system. Obviously, replacing failed ACs. Furnaces generally outlast ACs. Compressors don't last nearly as long as heat exchangers. So this is a good opportunity on older systems where people may not want to be upgrading their furnace, but want a heat pump or want a high efficient AC. We can help them out with that. Many homes still do not have ACs today. So this is an opportunity to be able to provide them with a high efficient AC or heat pump on an older gas furnace that they don't have their AC currently. Obviously, in the new construction, we can provide high efficiency, quality comfort, meet energy codes, and in a lot of cases, there are rebates available for these things. Furnace compatibility. These furnaces or coils are capable with anything that's thermostatically controlled and non-communicating, meaning anything 24-volt controlled. If you have 24-volt, your standard red, common, white, yellow terminals, this coil can be used with that. Anything that is DC controlled or communicating back and forth will not work with that. It has to be 24-volt controlled unless that furnace has the ability to be changed over to 24-volt controls for communication. Otherwise, you're going to be stuck with the 24-volt. Different fan motors We obviously can do single stage furnaces, 2-stage furnaces, or variable speed. So ECM, multi-speed motors, and PSC motors. And we'll get a little bit more into that a little bit later on, how to set that up. Features and benefits. So we have a pretty large variety of coils that can be installed to suit your applications. Our 18, 24, and 30,000 BTU coils come in 26 tall and either 14.5 or 17.5 wide. That way we can match up with your most common furnace sizes. Your 36 and 42s, they come in 31 inches tall, and again, 17.5 or 21 wide to match your furnace. Our coils are coil-only matchups with Mod 95 furnaces and some of those higher efficiency furnaces. We've seen SEERs over 20, which is pretty darn good for a coil-only matchup. Again, compatible with 24-volt gas furnaces, not approved for oil furnaces. That's important there to know. Your oil furnaces are burn a little bit too hot for these things, not tested, not approved for use on those things. So make sure you stick with gas or propane only. As far as controllers go, pretty much any of our Mitsubishi MA controls are simple to touch. Power 40s, those will work on this thing. MHK2s, Kumo Cloud, along with any of your 24-volt conventional thermostats using a PAC 445 interface. So if they want to retain their Nest thermostats, their Honeywell stats, they can do that with this. And we'll get more into that in a little bit. These coils are multi-positional. They come set up for either horizontal, left, right, vertical, up, or down. So give you some option there to play with there. The control box, which is this right here, that's where the brains of the operation are, can be mounted anywhere. It does not have to be on the coil. It can be mounted on the wall, it can be mounted on the ceiling, mounted on the floor, don't care, as long as it's within 5 feet of the coil. And the reason for that is the coil thermistors have to plug into that coil box. So they cannot be spliced, and you've only got about an 8-foot cord. So you need some little extra slack to be able to get in there without having too much tension on them. So within 5 feet. Balance points from when this thing switches from heat pump over to furnace. It's going to change a little bit depending whether you're using a hyperheat or a standard heat pump. As you can see, we have a pretty wide variety of balance points, ranging anywhere from -11 degrees to 32 degrees, or furnace only if you're using a PUI cooling only system. So with that, it's going to change a bit. Like I said, you start getting the negative degrees, it's going to be on the hyperheat units. 9 degrees and up, that's going to be on pretty much all of your units. That's the point at which your furnace is going to switch from the heat pump to the gas furnace automatically based on outdoor temperature. Capacity balance point, we'll get into this a little bit more. It's one of the most advanced in the industry. It's a learning capacity balance point. And again, we'll get into that here in just a little bit. Pretty cool stuff on that though. Efficiencies. Mitsubishi Intelli-Heat is beating all of our competitors by quite a bit on the SEER ratings, as you can see here. Due to AHRI requirements, all the testing is done with the worst worst wattage possible blower that we can get. So this is a PSC belt-driven motor with ECM motors. We're seeing efficiencies as high as 20.5 SEER, but because we have to rate them based on the worst case scenario, we're seeing about 17 SEER on a belt-driven motor. So that's pretty darn good. As you can see with your different one-to-one setups here, we have our SEER ratings, again, based on that belt-driven motor, along with our COPs. You'll notice our COPs in this thing are pretty darn good, even on at 5 degrees. Got a decent COP on these things. Compatibility and line set sizing. One thing to notice on this is on the 18K outdoor units, there is no matchup for that. There's also no matchup for the 42 hyperheats on the one-to-one systems. If you're going to use an 18K Intelli-Heat coil, you're going to use it on a 24K outdoor unit. Right now, like I said, we don't have any one-to-one matchups on the 42s. Mitsubishi is still working on that, and hopefully will be released here soon. For line set sizing, pretty much everything uses a 3/8, 5/8 line set, with the exception of this matchup right here. So a PUY 24 outdoor with a PAA 18 indoor coil is going to be a 1/4 by 1/2 line set. Notice there's a couple of asterisks next to those. If you come down here, you'll see you'll need port adapters for those on the 18 coil only. So if you're using the port adapters on the PUY, your port adapter is going to go on the outdoor unit. That way you can reduce the line set size going to the coil. If you're using on a PUZ, you're going to use your port adapters on the indoor unit. That way your line set size will remain 3/8 by 5/8. Right now, Gensco does not keep in stock the PA18 coils. It's not something that we think is going to be used too often, so it's not something we brought in. So be aware of that. Liquid line, vapor line, both still need to be insulated, just like a normal mini split, because of where our TXVs are, or linear expansion valves is what we call them. When you're using the PAA coils on these 1-to-1s, 100-foot maximum line set length. So it does change the specifications in the manual. Some of these things you'll see will go over that, but with the PAA coil, 100 feet. Recommend using DSB to check your guys' builds on these things to make sure you're getting it right. Multi-zone compatibility. So you see here, as far as the 42s go, we do not have any compatibility matchups on multi-zone ported systems. Restricted to 36s on branch boxes only. You notice we are restricted quite a bit on sizing for the ported systems. Reason being is on the ported systems, the largest port capacity we can have in any one port is 24,000 BTUs. So you also notice there are no 2 C20s on this thing. 2 C20s, they're all going to be too small. So 3 C24s ranging up to a 3 C30. Again, make sure to use DSB to check your compatibility and make sure everything is okay. On the ported style systems, maximum of 2 coils. Make sure you don't exceed that if you have a 3C, 4C, or 5C. You can only have 2 of the indoor coils, and your total connected capacity is restricted to 100%. It means you cannot oversize for the heat pump. If you're going off the 130% rule, will not apply with the Intelli-Heat coils. Have to stay to 100%. Come down here to the branch box systems. We have a little bit more flexibility of what's allowable. Again, pretty much the only thing that's not going to be is your 42,000s. Oh, one other thing I wanted to mention as well here on the ported systems. If you notice, it is restricted to a 3rd and 4th generation heat pump. So if you have an NA2, NA, any of that stuff, it's not going to work. It's got to be a generation 3 or 4 on the ported ones. Yeah, back to this here. Any number of PAA coils can be hooked up with the branch box systems. Just bear in mind that when you do that, your maximum allowable of indoor units drops either down from 3, 4, and 6 for SM4, SM5, or SM8 respectively. So if you have an SM4, your maximum capacity connected of indoor equipment drops to a 3. If you're on SM5, drops to a 6, and if you're on an SM8, your maximum indoor units drops to 6. So keep that in mind. And also, if you're working on an SM60, your maximum capacity is going to be restricted to 100%. Again, can't oversize for those. And also, again, no matchup on the 42s. Branch box lengths. You will see some different branch box length requirements when using the PAA coils. Your maximum line set distance is going to be reduced. Again, use DSB to verify these projects when you guys are building them to make sure you're building them within spec. And also, again, 33-foot minimum line set length when only PAA coils are connected. If you're using other equipment with the PAA, you don't have to have that minimum 33 feet. And that minimum 33 feet is total length, by the way. Any excess line set that's coiled up, again, has to be installed horizontally. Use DSB. Very important. Airflow. In order to get optimal efficiencies and humidity removal, we have to make sure the airflow is set up correctly. So here is some of the airflow requirements on the 1-to-1 systems. Please refer to your manual of your coil for airflow requirements on that. It's going to be listed obviously in the manual. Use airflow ranges listed for heat pump operation. The system uses the Y signal on the furnace to control both heating and cooling for the heat pump. It will not be controlling the W1, W2s because that'll turn the gas furnace on. Obviously, we don't want that. So your fan speed settings are going to be based on your Y signal. So when you're changing your dip switches or your pins or whatever you got, make sure you're changing it on the Y signal. We do have minimum and maximum rated airflows in each coil, so please make sure to match that up with your furnace. And you can see we got targeted ones. If you're using a downflow furnace, do not exceed 350 CFM. What can happen is you can end up getting too much airflow across that thing and blowing water off the coil and into your ductwork, flood out your house, whatever it may be. Not a good situation. Don't exceed that 350. Static pressure drop. So when you guys are sizing these things up, this will be an important one to make sure you get your static set up correctly. If you notice on our chart here, we have an A and B, it's highlighted in green and red. Those are for your coil width. So make sure you're paying attention to get your, when you're setting up or calculating your static, that you're using the correct coil width. Always use proper pressure drop for manual D calculations. Horizontal and upflow, downflow, all that stuff is going to change quite a bit. As you can see, as you get down here into the bigger coils, you do have quite a bit of static drop. So you want to make sure to size your ductwork and your furnace accordingly to be able to accommodate that. Refer to your installation manuals. In those, you will have an internal static pressure chart here, just like what we have. So what you do is you look for the equipment that you have, figure out what the rated airflow is, come down to your chart, come up to the line, and come on over here, 18-inch water column on a PA30, PA1, which you can see is right here. So that's an upflow. If you're horizontal, it's going to be 0.22. Make sure you match that up. That way we get proper airflow for you guys. All right, what's in the box? So you can see here, we got a picture of the Intelli-Heat coil. These are the thermistors that come pre-installed in the coil. That's again, those are the ones that are restricted to 5 feet from the control box. You also have this L bracket right here. We'll get into that a little bit, but that L bracket is just used to fill in the gaps on in front of your furnace if you have a gap down here where it meets. Let's go to the next slide. Here is the control box for the coils, the brains of the operation. It does ship loose in the box. Again, it needs to be installed within 5 feet of the coil due to those thermistor lengths. What's in the box? So it does come with just about all the accessories that you'll need for a standard installation on this thing, minus your thermostat controls. In the package, you'll have a couple of thermistors. You have a return air thermistor, which is this larger one with a bare copper end on it. And then also a non-adjustable thermostat that's set for 65 degrees. And that is this thermostat right here. It's got a red cover over the end of it. Both of those, this one, the return air temperature thermistor is going to be an important one. You'll have to use that. The non-adjustable thermostat will be used if you're using a Mitsubishi stat or a non-24 volt stat. And we'll get into that more in a little bit. It also comes with the bracket to mount those things into the return. It also comes with a condensate float safety, which is right here, along with a connector to plug this into the board. One thing to note is this condensate safety does not tie into your low voltage. Does not break your red and white. It is designed to wire into the control board on the CN4F connector. And we'll get into that a little bit more later on. But if you guys wire that into your 24 volt, you're going to get a thermostat error. Here's that L bracket that we talked about a little bit. Again, that doesn't come in the accessory bag, but it does come with the kit. Here is that condensate safety along with those thermistors that we talked about. Again, the bare copper one here is the return temperature thermistor. The red one is a non-adjustable thermostat. A few times I've been seeing guys get calls because they're having a thermostat error after they install this thing. They got these flipped backwards of where they're connected to the unit. The unit does not like to try to read the non-adjustable thermostat for the return temperature. It doesn't work. So If you're coming up with an error after starting it, good idea, check your thermistors, make sure you got them wired up in the right spot. All right, so typical installation. So you'll see here, we kind of have a view of a horizontal and a vertical installation. And this is the furnace we have in our training center of a vertical installation. You can see the coil sitting on top of the furnace there. Again, always make sure your coil's on the supply side of your gas furnace. You do not want it on the return. A couple things to notice on here is on a horizontal application, you have a drain pan and a top plate on this thing. In a vertical application, those are gone. If you're going to use a vertical, horizontal up or vertical up or vertical down, you'll need to make sure to remove those. Horizontal left or horizontal right, you will have those in there. These things come pre-shipped from the factory in the horizontal right position. So if you guys need to change that to the horizontal left, you'll take the drain pan out along with the brackets and move it to the other side. We have some slides coming up that'll show that a little bit better. Here is your control panel on the side of the coil, which is this guy right here. And you can see you got your return temperature and your non-adjustable thermostat coming down into your return. Does not matter too much where in the return it is. If you have any kind of return heaters for any kind of reason like that, or a zone system with a bypass, you will want to make sure that these thermistors are upstream of that so it does not affect the readings of them. You want a good accurate reading of the house. And again, this slide here is showing are the different positions. You can go upflow, downflow, horizontal right, horizontal left, depending on your needs for your design. And here's a better picture of the coil with the drain pan in the top place that I was talking about. Again, if you're going in a upflow or downflow, this drain pan will need to be removed and this top plate will need to be removed. That will give you better static pressure readings and create a little better airflow for you and not give you airflow problems. If your systems are pre-installed with these things, so if you're horizontal right, you do not need to do anything out of the factory. It is all set up and good to go for you. If you're horizontal left, you will be moving this drain pan and these plates right here to the other side of your furnace. Please refer to your installation manual for doing that. You can see here we have a upflow downflow application. So as you see in the picture, your horizontal drain pan, your top plate have been removed. This example of the horizontal left. So again, these units are pre-installed for horizontal right. So if you're going to change it to a horizontal left, you'll need to make sure to change your drain pan over to the other side there. And here is that L bracket we talked about earlier. So a pretty simple little thing. If you put this thing on top of your furnace and you have a gap between the furnace and the coil or supply plenum or whatever you may have, that little L bracket just screws into that place and can be sealed up there. Give a nice, good air seal. So this slide here is showing the different orientations of how we can mount the control box. Again, don't really care where you mount that thing as long as it's within 5 feet of the coil. You can mount it on the wall, you can mount it in the coil, mount it on the ceiling, mount it on the floor, mount it in your mother-in-law room. Don't really care as long as it's within 5 feet because of those coil thermistor lengths. Cannot extend those wires. So what you get is what you get. As long as you're within 5 feet, you're good. Don't try to go further than that. If you're mounting it to the coil, there are some no-go zones here. So I'm marked out here with the little stripes. Anywhere in the center of the coil, this is marked on the coils for you and in the installation manuals. If you try to screw into these areas here, you risk damage to the coil or drain pans. So make sure you stick to the marked area on the inside of the coils there to be safe. Do not use longer than 1/2-inch screws. If you guys try to run 2-inch screws into that thing, you will cause coil damage, and I promise you Mitsubishi is not going to replace that for you. Dimensions of the control panel is about 13.5 by 15 by about 5.5. So 13.5 this way. Or excuse me, 15.5 this way, 15 that way, and 5.5 inches deep. It is kind of a big clunky box right now. Mitsubishi, I believe, is working on trying to get the size of that reduced down. This is what the inside of our control box looks like. So you can see in here, we have a couple different boards. This is our main control board. This is where all your thermistors and everything, your Kumo clouds, MHK2s and stuff are going to wire here. And we'll get into a little bit more on that in just a little bit. You have two separate terminal blocks in here for low voltage wiring. Terminal block A, TBA, is for your furnace wiring. TBB is for your 24-volt thermostat controls. For those of you that have used the 24-volt interfaces previously and other equipment, this is a little different. Your thermostat will not wire into that 24-volt interface. It is going to wire onto this TBB terminal block. That wire will come on down to this relay board down here and will communicate with the system. Or if you have that 24-volt interface, it's going to come back up. We'll get into that. We have a slide of that connecting to a PAC 445 interface and show you how to work all that. On the outside of the box is this little control panel right here. So this thing has a couple different buttons on it that we'll get into. This thing is used for test operation only. Apologize. There is a couple of LEDs on there. So these upper, what look like buttons are not buttons. They're just LEDs for W1, W2, depending on which one's being used, which one's going to be lit up. Then you have normal operation, which will normally be lit up green, test mode, and emergency operation. So if your heat pump's not working, anything like that, you're curious to see if the system is actually an emergency operation, this little light right here will be lit up for you. Right here, you have your line 1 or your line voltage coming from the unit, from the heat pump, along with your communication. So your standard 14.3, S1, S2, S3 is going to connect right here and go to your heat pump. Behind this control board is the power board for this thing. Not much you really need to do on that thing. They put it in a nice, real easily accessible spot back there. Not really, but it's back there. Like I said, not much you're going to need to do with that. And here is an exploded view of the control board. So again, this is your CN105 connector that you're going to hook your MHK2 thermostats up to, your Kumo cloud, or your PAC 445 interface. A lot of the connectors on here are pre-set up from the factory. This one here is for your MA controller, which actually, if you come back on this slide here, if you're using a wired Mitsubishi thermostat, it is going to connect right here on the M1, M2. And it's factory wired into the MA control spot right there that I was just highlighting on the other slide, which is right here. So again, factory wired, shouldn't have to mess too much with that. Your return temperature thermistor right here. That one is also factory wired into the control board, and we'll get into that a little bit more in a little bit. So you don't have to worry about anything on there. These two plugs right here, this is your float switch for your CN4F. So that condensate safety switch that comes in the kit that does not plug into your 24-volt controls is going to plug in right here. So in the kit comes a little pigtail with a plug-in. So you'll wire nut your condensate safety switch into that, and it'll plug into right here. Your coil temp thermistors, TH2 and TH5 pipe thermistors that are wired onto the coil. They're going to plug right here into CN44. All right, and here we have our connection diagram for the S1, S2, S3, so your power and communication from the heat pump to the indoor coil. Nothing's really changed on this from the other M&P product series. You're going to want to make sure to use a 14.3 stranded shielded on this if possible. Yeah, typical S1, S2, S3. Disconnect switch, make sure to use a 3-pole disconnect when required. So Mitsubishi does not require these on the system. That is up to local codes. If your local code requires a disconnect, then you will want to use a 3-pole disconnect. If you use a 2-pole, then you can still have high voltage on that S3. Dangerous situation. Don't want to put anybody's lives at risk. So make sure to use a 3-pole disconnect on that. All right, getting into more control wiring. So this is the TBA and TBB terminal blocks that are in the control box. Again, your TBA is where your gas furnace wires to. TBB is where your thermostat wires into. if you're using a 24-volt thermostat. Conventional thermostat wiring is acceptable on this, 18 gauge. Again, if you're using a Mitsubishi thermostat, it's going to wire into M1, M2. Make sure you follow the requirements for the Mitsubishi thermostats on that. Your relay board is down here on the bottom. Your return temperature thermistor. So this is the one where the guys get mixed up that I was talking about earlier. That thermistor with the bare copper end on it is the return temperature thermistor. It is going to wire into here to TH01 and RTN. If you're using a non-adjustable thermostat, which is on the next slide I'll show you, it's going to wire into your thermostat controls over here. And if you're using a 24-volt thermostat, you do not need that non-adjustable stat. But again, furnace is going to wire up on the left on the TBA. Your thermostat and your temp sensors are going to wire up on the right on TBB. And then your S1, S2, S3 is going to wire up the TBC. All right. This is that non-adjustable thermostat wiring I was talking about. So in the event that there's a power outage to the heat pumps, the heat pump goes into an error, it can't communicate anymore, but the gas furnace is still operational, the system will automatically switch over to the gas furnace to provide backup heat. If you're not using a 24-volt thermostat, so if you're using a Mitsubishi communicating thermostat, that is powered by the heat pump. So if your heat pump goes out or has any kind of errors, thermostat can no longer communicate. It is going to automatically switch over to this non-adjustable stat. The one that comes in the kit, again, is set for 65 degrees. You are going to wire that on the TBB terminal block between red and W1. If you have a two-stage gas furnace, you'll just do a jumper between W1 and W2 to bring on that second stage right away. Again, both the thermostats will wire or will be installed into the return air of the system. And make sure you do not flip those thermostats around, because once again, like I said, you will come up with an error code. Also, if you are using a 24-volt thermostat, once again, you do not need that non-adjustable thermostat. Furnace control signals. Pretty much standard stuff. You know, your red is your 24-volt. You're going to wire your furnace into your TBA terminal block. So you will need red for 24-volt, common, your W1s and W2s if you have a two-stage, and your G and your Ys and your Y2 if you have a two-stage. One thing to note, and we'll get into this a little bit more here, is your fan speeds on your Y, Y1, Y, and G. So the heat pump is going to run off of the G and the Y terminals. It doesn't run off of the W, because the W's will turn on the gas heat. We don't want that. So if you're running a one-stage furnace, you're going to connect G to the G terminal and Y to the Y terminal. That way you have your fan control and your call for fan and cooling, essentially. If you have a two-stage furnace, you're going to jumper G and Y1 together and wire them together right here. And your Y2 is going to wire up to the Y2. And again, we have more wire diagrams in this a little bit later in the slides. We'll get a little bit more into it. Mode settings for the fan speed. So one thing that you guys are going to be aware of is when you're programming your thermostats or your dip switches, what's in like your MHK2 manuals and stuff is going to be a little bit different in Intelli-Heat. They're going to have some different meanings in there. So you're going to want to make sure to read your manuals to make sure you're setting these things up correctly. If you're used to just your standard setups, you may end up having some issues with this. Mode 23, which is normally in your MHK2 manuals and stuff, is going to be for your auxiliary heater control during emergency operation. On this setup, it is going to be selection of either one-speed or two-speed fans. So single stage versus two-stage furnace. So again, make sure to read your manuals on these things and the Intelli-Heat coil of what your modes are. Initial settings and these things from the factory is set up for a single stage. So if you're using a two-stage furnace and you're using Y1 and Y2, you're going to need to make sure to come into your mode selections and change that to mode 2. That way it actually knows that it's connected to a two-stage furnace and it doesn't just try to run first stage all the time. How the two-speed fan control works. So again, if two-speed fan control, you have to have mode 23 set to 2. If you're running auto fan in either heating or cool mode, usually we recommend you guys run high-speed fan just because it gives you 100% capacity typically. But if you do have them running in auto and cool mode, how it's going to work for the second speed fan is the room set point or temperature needs to be equal to or greater than 3.6 degrees from set point. So if it's 3.6 degrees or more, it'll kick into the high speed fan. It'll run high speed fan until it gets down to equal to or less than 1.8 degrees from set point. Once it gets down there, it'll switch back over to first stage fan and run first stage fan. Dry mode does not allow a high speed fan operation. It will only run the low speed if you're running a two-stage furnace. Dry mode, we don't want to overshoot the room. We just want to try to pull out some of the humidity in there. So high fan speed is not wanted and not an option. And heat mode in auto fan. Same kind of principles there. If we see more or equal to 1.8 degrees from set point for 3 minutes, it'll switch to high speed fan. Once it gets down to equal to or less than 0.9 degrees from set point, it'll switch back to the low speed fan. Float switch. So this is the float switch that comes in the kit. As you can see, it plumbs into the secondary port on your coil. This thing needs to be plus or minus 10 degrees from level. Most guys can eyeball that, but for the ones that cannot, recommend using a level. That's not provided in the kit, but they do give this cute little cutout gauge to help with the leveling on that thing. Again, most people probably won't ever use that, but it's there if you need it. This is the condensate switch that is going to wire into that CN4F plug, not the 24 volt. So it comes in the kit. It's got the little plug with the about 12-inch lead pigtails. That's where this is going to wire from. So in the float switch, there is an adjustment on the top of it to adjust that float up and down. The proper adjustment for this, why it's not set up from the factory, I'm not sure, but it should be 3 rings high. So if you're looking at the top of the plate there, once the thing's all mounted up, you should only see 3 thread rings sticking out of the top of that thing. That is properly adjusted. Make sure that is set up from the factory. Here's a nice close-up view of that 3 rings. Control box interface. So I talked a little bit about this earlier. This is the interface on the outside of the control box. There's only 3 buttons on this thing. Don't mistake these ones up here for buttons. Those are just LED lights. This is for testing operations only. So on the coil or the control board, on the relay board, there is a SW01 dip switch bank. When using that, you will be able to test the gas furnace operations on that by initiating test mode. Again, the only operations you're going to be able to do is test mode on this, and it's either going to be first stage heat, second stage heat, or turn them both off. These up here are all just LEDs indicating what mode it's in, whether it's a normal mode, test mode, or emergency mode. This is that little dip switch I was just talking about, SW01 on the relay board. Again, this is the settings to set up the test mode operation. One thing that's important is SW01. This is what powers your 24-volt thermostat. If that is in the off position, you will need to require a 24-volt transformer to power your 24-volt thermostat. If you turn it to the on position, it will get its power from the furnace. These things are supposed to default as the on position from the factory. We have been seeing a few of these things that are coming off from the factory, so you're going to want to make sure that the SW01 on the relay board is turned on. For the SW01 number 4, for your test mode operation, there are some instructions here we'll be going through of how to use that. Again, only used for test mode. And here is the test mode operation, how to do that. In order to get it into the test mode, you're going to turn your power off to your heat pump for about 3 minutes. And then after that, you're going to set SW01 number 4 to the on position and power the furnace back on. Outdoor unit will need to be remain powered off. Verified test mode is illuminated on the control box, and then you can use the W1 and W2 on the control box to test the first stage and second stage gas furnace if available on second stage. To get it out of test mode, you're just going to power everything back off, turn SW01 number 4 back off, and restart the system and verify normal mode is indicated in green. One thing to note on these things is if you guys are doing power cycles on the system, we need to treat this thing as if your indoor equipment is powered separately from the heat pump, meaning that your indoor equipment needs to be powered on before the heat pump is. So make sure to power up the furnace first and then heat pump when you're doing power cycles to avoid any kind of communication issues. Emergency operation mode. Again, what will happen is if a heat pump goes into default emergency operation, if something happens to the heat pump where it goes in error code, loses communication, or sees that it's powered off, won't need to do any dip switch changes on that thing. It will automatically switch over for you, and it'll be indicated by emergency mode indicator is lit up red. And at that point, either your 24-volt thermostat or your non-adjustable thermostat will control the furnace operation. Balance points. So I touched base on this a little bit earlier as far as the mode settings and different balance points that this thing has. So the balance point to switch over from gas heat or from the heat pump to the gas heat. So outdoor temperature. This will be settings done through your MHK2s, your Kumo Cloud, or your MA controllers, or if you're using a 24-volt thermostat, it's going to be done with dip switches on your PAC 445 interface. Default from the factory is set up to 32 degrees ambient outdoor temperature. So once it hits 32, it's going to stop running the heat pump and it's going to switch over to the gas furnace. Those settings can be changed using the mode selection in your function settings. Again, I was telling you about that earlier. If you're looking at your standard thermostat manual, this is going to be different. These are normally your static pressure settings. On the Intelli-Heat coil, it is now going to be your economic balance point. On your standard heat pumps, your range is 9 degrees, 14 degrees, and 19 degrees, all the way up to 32, 27, 32, or furnace only. On your hyperheats, you're going to have a little bit lower temperature changes on these first 3 here, just because it's a hyperheat. Again, you won't have to do anything with that. Once the system's connected, it'll see it's a hyperheat and it's automatically going to default to those if it's set to these. If you're using a PUY, cooling only outdoor unit, you're going to want to make sure to switch this mode to furnace only. Otherwise, you're going to have a hard time getting heat out of that cooling only unit. Capacity balance points. So this is the fun part. So these things are learning units. So what will happen is, even though if you may have your capacity or economic balance point set to, say, 5 degrees, example. If your system is running and it's been running for longer than 25 minutes and it sees that it's not dropping the temperature by more than 0.9 degrees below the set point or gaining any kind of temperature, it's going to automatically switch over to the gas furnace. Just saying, hey, I'm seeing my balance point is set to 5 degrees, but I'm at 18 degrees and I can't keep up. I'm going to switch over to the gas. This is self-learned over time and will change itself, but also unlearns one-time events. So if there's a window open, doors are open, kids are running in and out of the house, whatever it may be, if it has that changeover, it's going to revert itself back. So it's going to take time for it to relearn itself to make sure everything's okay, but it will do it. So what will end up happening is once it sees that one-time event, the next time it goes through its startup, it's going to slowly work the temperature down. And if it doesn't see a temperature change within 24 minutes, it's going to revert back to its learned balance point. But if it sees that it is gaining temperature on its own with just the heat pump, it'll continue to run the heat pump and adjust itself. Here's an operation of how that kind of works. So you can see is in our lines right here. This is our compressor frequency. The red line here is when the gas turns on. So set points change from 64 to 68, and the thermostat rose 0.7 degrees in 24 minutes. So it did not hit that 0.9. Gas furnace replaced the heat pump as a primary heating until it reached that point. Seeing that right here. During this time, the reported set point changed to 59. When unit satisfied, the reported set point changed back to 68. So when it's running the gas furnace, one thing it's going to do is it's going to stop looking at actual return temperatures, and it's going to assume temperatures until the thermostat tells it otherwise. But you'll see in here that once it hits its set point, it goes back, switches the furnace off, and it goes back to running normal cooling or normal heat pump mode again. Controls. So this is the different controls that we can run on these things. Again, a pretty wide variety of controls on there. You can use a PAR 33, PAR 40, simple MA, touch MA, MHK2, Kumu Cloud, or a PAC US 445 only. So if you guys still have any of the old 444s lying around, that will not work on this. You have to use the newer PAC 445 if you're going to use a 24-volt thermostat. Like I said, if you're going to use a 24-volt thermostat, PAC 445, got to have it. This is the PAC 445. Again, 444 is not compatible. So if you got any of those lying around, not going to work for this. With the 445, they did make some improvements to the defrost cycles. In order for those changes that make effect, SW1 number 1 needs to be turned off on the dip switches inside this thing. So if you turn that back on, you're going to change the defrost cycles back to what we were having on the 444s, and you could potentially have some issues with defrost on these things. The new 445 does have updated dip switch settings. So if you're used to using the 444s, make sure you read the installation manual on the dip switch settings because they have changed. So you want to make sure that you're setting these things up correctly with the 445s. Allows direct connection to the PAA relay board. So you do not need a transformer on this one if you're using it on the PAA. It's going to steal power from the furnace. If you're using this, the non-adjustable thermostat is not needed because you have the 24-volt thermostat in its place. You still need that TH1 return air temperature thermistor. Got to have that one. So this is the control board. This is our PAC 445 up here. One thing to note on this is if you guys have used these 24-volt interfaces before, these are a little bit different. Your thermostat does not wire into the 445 on the Intelli-Heat coil setup. It comes with a pigtail, which was this guy right here, this little pigtail. This is what wires into the 445 right here. This pigtail is going to wire into your control board or the relay board down below here. See that right here? It comes down and wires into that. Your thermostat is going to wire onto the TBB terminal blocks. And then from there, it goes down to the relay board. That way the system can control everything, and then it communicates back to the 445. 445 does still have the CN105 connection. So you need to make sure that that's plugged in, wire up that pigtail. You should be good to go there. And also, again, on the relay board, SW01 number 1, even though it's supposed to be default from the factories on, verify that it is indeed on. Here's a wire diagram we have for you guys, and we will be sending this presentation over to you guys so you have a copy of it, so you'll have this wire diagram. This shows how our 445 is going to connect and how it wires up. So you can see this is that pigtail that comes in the kit, plugs into the relay board, comes up, it's going to wire into the 445. 445's got this plug, it plugs into the CN105. Your thermostat is going to wire into the TBD terminal block on the coil. Do not wire it into the 445. And then your furnace is going to wire into the TBA. And whether you're using a one-stage furnace or two-stage furnace, you will have a jumper between G and Y1 if it's a two-stage, If it's a single stage, you just wire up G and Y1 only. And this slide here, just kind of go over that too. Again, make sure the SW01 that is circled back here. The SW01 relay is right there, our dip switch is right there. So make sure SW01 number 1 is turned on. When you're programming your 24-volt thermostat, make sure to set for conventional systems, not heat pump or dual fuel. This system is designed to operate as a gas furnace with an AC. So as far as the furnace is concerned, there's not a heat pump connected to it. It just thinks there's an AC and there's something calling it, telling it to turn the AC on. The heat pump is doing the rest of the work from there. So conventional system, gas furnace with AC, not heat pump or dual fuel. Again, this system is compatible with Kumo Cloud, and using the Kumo Cloud app, you can do your function settings with your balance points. You will have to have the interface requirement. So you have to have the interface that plugs into the CN105 in order to use the Kumo Cloud app. It does not come with it, and it does not come with the MHK2. So this is a separate interface you have to buy, just like normal. Again, through the Kumo Cloud, you can go through, you can adjust your balance points, your fan speed settings, humidifier controls, humidity controls, furnace delay, auto mode changeovers, etc. This is just kind of goes through what it kind of looks like when you're going through the Kumo Cloud app to see what those settings look like. And if you guys need help with that, please give us a call. And that is the end of our presentation. So at this point now, we can open up. Looks like we've had a few questions. Looks like Aaron's been answering them. Aaron, you still with us?
I am.
All right.
So one of the questions we had was, can you do an oil furnace if you put the coil 6 inches above oil furnace? And unfortunately, the installation instructions specifically state that we can't use the PAA coil with oil furnaces, so that's not an option, and staying within the manufacturer's guidelines. And then we had some questions on ratings, and due to AHRI's issues with manufacturers pushing a lot of ratings this way because of all of the Tier 2 HSPF2 changes. Still having some issues getting all of those published, and as soon as we can get more of those published, we'll get them out. Your sales rep will get them out to you. We also had a question about if we could, instead of taking that coil and converting it from horizontal right to horizontal left, if we could just blow into the top of it. And the answer is that we need to convert it properly, because we've got that top plate on there. So blowing into the top of the coil would cause some airflow disruption issues inside the coil, so we don't get air through the bottom part of the coil slabs themselves. If we're to pull that top plate off, then we would have water blow off issues. So we really do need to convert that properly. Let's see. We had a question: is Mitsubishi planning on updating Kumo Cloud? Some people don't like the current interface, and the answer is yes. That is a big initiative within the controls division in Mitsubishi. They are actively working to update Kumo, making it easier. You guys have probably seen, for those of you who've done Kumo for a number of years, you've actually seen improvements over the last couple years, making it easier to install, easier to program, all of that. They are working on a major refresh to the user experience on the app itself. So, but that takes a little bit of time, and they're working on it.